Welcome to 5.3. This is our last video of this unit. So very exciting, you're almost done. So graphing quadratic inequalities in two variables is very, very similar to taking our graphing quadratic functions from unit 2 and then taking that coupled with our lesson previous to this where we were graphing linear inequalities. So we're just doing those two things together. So what I really encourage you to do when you're interpreting these equations is really just think of it as y is greater than my function, my output of this function. Similarly here, y is less than the output of my function. If you think about it like that, that might help you understand these graphs a little bit better. So keep that in mind and maybe think about it that way. I'm going to encourage that as we work through the examples. So example 1. We've got graph y is less than my output. Okay, so that means y should be below my graph, just kind of as a different way of thinking about it. Because we're looking at it in 2 dimensions, so underneath the function. But otherwise, we already know how to graph this if it were y equals negative 2x minus 3 squared plus 1. This is vertex form. So I know my vertex is at 3 and 1, and I know that my shape is going downward, so it's a maximum. Okay, and I know I'm going to have to multiply my typical values by 2. So you can think about it as plugging in, or however you want to think about it. Make a table of values, come up with however way you want to represent this. So I'm going to plot some points in order to get this quadratic on my grid. I'm just going to go up by 1 on my scale since we're just dealing with 3 and 1. That's not too shabby. Okay, so I've got my vertex is here, 3 and 1. From there, I can figure out that 2 minus 3 is 1 squared is 1. Times negative 2 is negative 2, plus 1 is negative 1. So that gives me my next point. And remember, symmetry means I should get matching ones. I go here, 1 minus 3 is negative 2, squared is 4, times negative 2 is negative 8, plus 1 is negative 7. So already I'm going down 2, 3, 4, 5, 6, 7. And my next point is here and here. So those are my points for my parabola. I'm ready to draw it. Now I need to go back to this less than or equal sign though. I'm like, oh right, it's not equal to. So instead of a solid line, I am going to draw a dotted line. There we go. Again, dotted line to represent greater than or less than, but not equal to. So I've got my dotted parabola. Now my y is below my function. That's how I'm going to think about this. So automatically I'm going underneath my function. Well, where is that? Well, it's on the left, on the right, in the middle. Like, where is that? Well, we can test some points to figure it out. So again, remember, when you can use the origin, it's not a bad idea. Then I'm going to choose another point on my x-axis just because why not? As many zeros as I can. So checking for my inequality, I'm going to use my origin. So that's going to be 0 is less than negative 2 times 0 minus 3 squared plus 1. So 0 is less than negative 2 times negative 3 squared plus 1. 0 is less than negative 2 times 9 is negative 18 minus 1. That's still going to be a negative number. Is 0 less than negatives? No. So this does not fly. So instead I'm going to check inside the parabola. So origin was outside the parabola. This next point is inside the parabola. It's 3 and 0. So still 0, but negative 2, and then 3 minus 3 squared plus 1. So 0 is less than negative 2 times 0 plus 1. Well, that's 0. So positive 1 is greater than 0, or 0 is less than positive 1. Well, that is true, which means that when I go to decide outside or inside, my inside point worked. So I'm going to shade inside my parabola. Done. Next one, same process, just instead of vertex form, now we're looking at general form. So we can find some different information about this quadratic. First of all, I look at the statement and I say y is greater than my output of my function, so y should be above my function. That's what that means. So now let's figure out some information about this. If it was y equals x squared minus 4x minus 5, that would be the same as x minus 5 and x plus 1, which means that my x-intercepts are at 5 and negative 1. My y-intercept, remember, is just my constant for my general form. So that's going to be at negative 5, and I've got some points. So let's plot them in here. Now, whereas the other graph, I had skewed my axis down upward so that I had more room underneath because it was opening downward. Here, I've got most of my graph is going to be happening below as well. Does this make sense? Oh yeah, I don't have my vertex yet, so I still need to find that out. Okay, but it looks like my vertex is going to be below because I've got my y-intercept at negative 5. So I'm going to have to figure that out. Well, what's halfway between those two guys? Halfway between 5 and negative 1 is going to be positive 2. So that is my x value. So vertex is positive 2, and plug that in. 2 squared is 4. Minus 2 times 4 is 8. Minus 5, so that's going to be negative 13 plus 4 is negative 9. So I'm definitely going to need lots of room below my y-axis, below my x-axis again. So again, I'm going to skew it upward. My origin's going to be way up here. And I need to go, I'm still going to go only up by 1 though. Now I just need to plot my points. So I've got an x-intercept here, an x-intercept at 5. My y-intercept is at negative 5, and my vertex is at 2 and negative 9. And remember symmetry, so I get a little bit of that going on. And I can even figure out some in-between points if I wanted to. So there we go. Parabola, check. Am I going to do a dotted or solid line? Because it can be equal to, I'm going to do a solid line. Solid curve, more like. Okay, and I said above my function, so I'm already thinking it's going to be in here. But we're going to double check, choose some points. My origin this time is nicely inside, and I'm going to choose maybe a y-intercept that's below my parabola this time. I always like to choose on the axes, and then if I use my origin, I can always compare, do I actually go onto the opposite side of my quadratic? So I'm always making sure that I'm actually using values that are on contrary sides. So first things first, 0, 0 plugs in, and we get 0 is greater than or equal to 0 squared minus 4 times 0 minus 5. Well, that's 0 and that's 0. 0 is greater than or equal to negative 5. That is true. Check again. We've got 0 and negative 9. Well, does that work? We've got negative 9 squared minus 4 times negative 9 minus 5. Well, that ends up being 81 plus 36 minus 5. Well, this is definitely a positive number. And so 0 is greater than or equal to a positive number. That is not true. So this point is invalid, but our origin is, which means I'm going to shade here. Now, it just so happens that these two examples end up where we're shading inside of the parabola, so inside the curve. You can end up with scenarios where you shade outside the curve instead. It just didn't work out that way in these two examples. So example 3, Sam and Jared want to learn how to rock climb. They've enrolled in one of the summer camps in southern BC. In the brochure, they can across an intersecting fact about the manila rope that is used for rappelling down the cliff. Okay, I'm not sure what that means, but we're going to run with it anyways. Okay, it states that the rope, okay, so some sort of rope that we're using as we're going down a cliff, can safely support a mass of m in pounds, modeled by the inequality m is less than or equal to 1,450 multiplied by d squared, where d is the diameter of the rope in inches. So that sounds kind of crazy. Like, that's a huge number, but you have to remember that the diameter is in inches, and so inches are a pretty small measurement, and usually ropes are not super thick. So even when we think about the fact that an inch is about this big, well, a lot of ropes are not even that thick. So we're dealing with a fraction here, so we're only taking a portion of that 1,450. So we're going to graph the inequality to examine how the mass that the rope supports is related to the diameter of the rope. Okay, so first things first, we look at the equation and we're like, okay, well, is that vertex form or general form? You could argue that it's either one. If we think about it in terms of vertex form, I'm just rewriting it down here for comparison's sake. Well, my vertex form is y equals a x minus p squared plus q. Well, there's nothing being added to my variable before it's squared. There's nothing being added after my function. That means that my vertex is 0, 0. If I look at it in general form, which is ax squared plus bx plus c, again, there's nothing being added here, which means my y-intercept is 0. And there's no factoring it in terms of binomials or anything, so I'm not going to be looking for multiple intercepts. It's just going to be my one intercept, and that would be, if we solve for it, it's also going to be at 0. So we would divide by 1450. Now, you don't need to be writing this. I'm just kind of proving it to you. If you want to write it, go ahead. Square root of d, square root of 0, so that's plus or minus 0 is less than or equal to d. Well, but actually we can just use the equal sign here when we're going about our business for this part. When we're just solving for our intercepts, you can use an equal sign. So based on all this, my x-intercept is at 0. So it kind of all agrees with each other. So when I go to graph this, the only thing that I really need to bear in mind is my axes. I'm only going to use positive axes because you're not going to have a negative mass, nor are you going to have a negative diameter. And then I know that my origin is also going to be my x and y intercept and my vertex. And because this is really steep, when I go to draw it, it's going to be really, really narrow. Now, why did I use the solid line? Again, because it's that less than or equal to. Now, where is less than my function? Again, you could check some points. You can plug in different values, maybe choose one on the x and one on the y. Since our origin is right on the line, we can't use that. Okay, alternately, you can use that strategy we have of reading it and saying, okay, well, the mass, I should actually change these. So mass, diameter, mass needs to be less than my function, the output of my function, which means I should be shading below my curve. Now, even though it just looks like it's on the right-hand side, technically because it is constantly moving outward, just really, really narrow, it would be on the right-hand side. But if you don't believe me, you can check, choose any point on my x and y axis, so 5 and 0, or 0 and 5. Plug those in, and you would find the same scenario. Okay. Two numbers are related in this way. 4 times the square of one number, I'm going to call that one number n. Okay, 4 times, and we're also going to be squaring that one number, is less than, that's kind of important, 2 times the sum, you know, yeah, we'll square that as well, of the other number and 3. Okay, it says graph and list 3 pairs. Well, before we do any of that, we need to write an inequality to describe this. So 4 times the square of a number would be represented like that, is less than, but not equal to, 2 times the sum. Okay, so that means 2 is affecting everything that we're adding together. And that's going to be the other number and 3. So I've got my inequality written, that's great. I want to write it in a fashion that's going to let me put it on the graph quite easily. Or you can just make a table of values, whatever you want. But I personally like creating an equation that I can work with. So isolate one variable and go from there. So I'm going to isolate m, and I'm going to say m is my dependent. So I'm going to divide by 2 to get rid of it, so that I can then deal with what's inside the brackets. So that leaves me with 2n squared is less than m plus 3. I'm going to subtract 3 from both sides. And that's going to leave me with 2n squared minus 3 is less than m. Now, if you don't like reading it like that, you're more than welcome to write it as m is greater than 2n squared minus 3. If you flip it around, just make sure you also flip your inequality sign. Now I can graph this because, well, it's a quadratic equation. So I can identify my vertex, if we think about it in vertex form, would be 0 and -3. If we think about it in general form, my y-intercept is at -3. And if we go ahead and try to factor it, we're going to be dealing with my x-intercepts are going to be at positive and negative root 3 over 2. So that's a little ugly. I might not want to use those. But from here, I can figure out everything. So I'm opening upward. That's another thing. So this is a minimum. So I'm going to maybe put my y-axis a little bit lower down, but I'm not going to call it my y-axis. Or x-axis. I'm going to call it n, and this is going to be m, so I can keep track of which relates to what. From here, put my grid in. Scale can still be just 1. No reason not to. Okay, vertex is at 0 and -3. That's also my y-intercept. It's opening upward. Square root of 3 over 2 is going to be somewhere here-ish. And here-ish. So I'm going to use some actual values to find some other points. So if I plug in that n equals 1, 1 squared is 1, times 2 is 2, minus 3 is negative 1. So that allows me to find some actual defined points. Again, if I plug in 2 squared is 4, times 2 is 8, minus 3 is positive 5. And I get these guys here. And again, the reason I'm able to do it on both sides is because we know that parabolas are symmetrical around their vertex. Because I don't have that equal sign in my inequality, I'm going to do a dotted line. Okay, so I've got my parabola drawn, check. Dotted line, check. Where exactly is this true? Well, again, I can choose values, origin and x-axis point, origin and a y-axis point, whatever you want to do. Or I can interpret this. So my output is greater than the output of my function. So again, actually, I'm going to be shading above my curve, which ends up being inside my parabola. But we did see, remember, that we can shade on the outside here. So that's graphing it. That's A. B says just list 3 pairs of integers that would work. That literally means you can choose any point inside your parabola. So I'm going to choose these ones. So that means that for B, my answer could be -1 and +2. It could be 0 and +4, 6, 7. Or it could be +2 and 7. And all of those are completely valid answers because they're all in that shaded area. So that's actually it for this lesson. Congratulations, you are now almost done this unit. So do some practice questions, take your assessment, and you'll be ready to move on.